So today we're going to talk about similar polygons. This is chapter 7.3 in the textbook. Welcome to go back to 7.3 and read the book as well. So here's the idea. Similar polygons have the same shape. One is a magnification of the other. And this magnification is called the scale factor. It could be times 2, times 3, times 3/2, or times 1/2. For the polygons shown at the left, ABC is similar to EFG. These are quadrilaterals. They look to be trapezoids. We're not really sure. This sign is similarity. That's a similarity sign. So it looks to be, if I was to place this quadrilateral in this one, it looks to me that this one would be maybe 1/3 of the size of this one. What do you guys think? Yeah. So one way you could think about it, the scale factor is, let's see, to get from here to here, actually, you would be multiplying the, oh my goodness, that's no good. Let me erase this. You would be really multiplying ABC by maybe 3 to make this fit into this one, or you could think about it as being 1, 2, 3. Okay? Here are some definitions. Two polygons are similar if corresponding angles are congruent, and corresponding sides are proportional. And here we go back to what we learned yesterday about proportionality and how to deal with proportions, actually. So what does that mean to be congruent angles? That would mean angle A would match up with angle E. Angle B would match up with angle F. Notice how I'm looking to see how they're lined up in this sentence, this similarity sentence. And so on. You might want to fill in angle C equal to G and angle D is equal to angle H. Corresponding sides proportional would mean like the ratio of AD would be the same AD to EH would be proportional to AB to EF. Would be in proportion to BC to FG, would be in proportion to CD to GH. So those would all have the same ratios and their sides are proportional. Are these polynomials similar? Be sure to check everything. Okay, well let's check the angles. Let's see, I see an 80 and 80. I see a 120 and 120. I see a 65 here. Uh-oh, but I don't have anything here. But if you remember the quadrilaterals, add up to 360 and do the math out. Let's see, 120 and 80 and 65. If you do that math out and subtract it from 360, you'll get 95 degrees here. Likewise, if you add 80, 95, and 120, subtract that from 360, you'll get 65 degrees. So we have determined that the angles are congruent, which is one of the definitions. Now we have to check the sides. Both has to be true. Both have to be true for polygons to be similar. So let's see. I guess we can look at 10 and 15. And let's look at that with 2 and 3. Do we have any more? We have 4 to 6. And we have 6 to 9. And if those are all in line, which they are, this is a 10, these would be proportional, and so we would do check. So the answer is yes. What is the scale factor for this one? The scale factor would be 2 to 3. That's the scale factor. Okay? So let's look at triangle ABC, and here's a typo here. Sorry, this should be a similar sign here. If ABC is similar to DEF, find angle X. Sorry, find side X. So we set up a proportion. You have some choices. You could do 2:6 as 5:X, or 2:5 as 6:X, which are all the properties of proportionality we learned yesterday. So I'm just going to make my decision. 2:X as 5, 2:6 as 5:X. Cross multiply. X equals 10, 15. Okay, let's go to the next example. Example 4. Suppose that ABCD is similar to EFGH. Let's look at the scale factor. Well, looking at it, I can see that CD is 30 and GH is 40. So it feels like, well, it's true that if these are proportional, it would be 30:40 has to be a proportion that works, or a ratio that works. So the scale factor will be 3:4. 30:40, 3:4. So let's fill in some of the unknowns by using the information that we know. Okay, well, let's start with the angles. If this is 50, angle D is 50, angle H must be 50. Angle E is 100, which matches up with angle A. That must be 100. Angle B and angle F have to match up. And then, of course, we can do our leftover math from 360 to find that this leftover has to be 90 degrees. If you subtract everything from 360, so this has to be 90 degrees. Now we have to deal with the proportionality of the sides. So we know that the sides have a ratio of 3:4. So if I look at this one, which is AD, we know that the ratio of A over D has to be A over D to 24. So if you cross multiply, you're going to get, let's see, 3 times 4 is 12, so you'll get 72 equals 4 times AD, divide through by 4, and you'll get that AD equals 18. So this would be 18. Let's look at AB. So we have AB, which is, this one is to 20. AB is to 20, as 30:40, or 3:4. So cross multiplying, we get 4 ABs equals 60. So AB has to be 15. And I'll let you fill in the last one for a little exercise, and we'll check that in class tomorrow. Okay? So the perimeter of of quadrilateral ABCD would be the sum of all the sides. If you sum up ABCD, 18 plus 15 plus 12 plus 30, you're going to get 75. If you sum up these, if you did your algebra right to get this guy, GH, you'll get 100, which is a miraculously, coolly 3:4. So what number did that look like, the ratios of the perimeters? Well, that looks like the ratio of the scale factor. So we notice that the ratio of the perimeters is the same as the scale factor. Okay, going to the next page. So a handy-dandy fact up here is that the perimeter ratio equals the side ratio, or the scale factor. Side ratio is also known as the scale factor. Okay, so let's do example 4 together. Actually, I'm going to have you try example 4 and 5 because those are all related to what we just did, and we'll come back and we'll look at those answers tomorrow in class. But let's go down to this important fact, because what we should have seen from the exercise above is the important fact is that similar polygons must have both corresponding angles congruent and corresponding side proportional. And we'll talk further about that in class tomorrow.